Hey there, in this video we're going to be talking about acids and bases. So the definition that we are using is the Arrhenius definition. Make sure that if you go online to find um, information about this that you're using the ARRHENIOUS definition because the other definitions are going to be a little bit confusing. So for what we need in this class, this is the definition that works for us. So let's first define what an acid is. An acid is a substance that when you put it into water or when dissolved in water, it's going to donate a hydrogen ion right here. So a substance that donates hydrogen ions. Let's talk about what this means. If you have HCl, so HCl is an acid that we have in our stomachs, hydrochloric acid. It helps to break down food. It's in our gastric juice, actually. And so if we put hydrochloric acid into water, it's going to dissolve or dissociate into its constituent parts. So here we're going to make water, or H2O. And hydrochloric acid mixed with water, it's going to dissolve, just like if you put an ionically bonded substance in water. Water is the universal solvent. So what's going to happen is it's going to break down into a hydrogen ion, H+, and Cl-. And if you look here, the HCl, the hydrochloric acid, which is like a white powder that you can put into water and it'll dissolve. So when you put that powder into water, like we have here, you have water, you can see the H2O. And then you have these H+ ions and these Cl- ions, or these chlorine ions. Now, the chlorine ions will come into discussion later, but it's not really important for this discussion. So yes, there are chlorine ions here, but disregard that. What's important is that we have these hydrogen ions because that's the definition of a base. I mean, an acid, sorry. So when you put hydrochloric acid into water, it's going to dissociate, and one of the products is a hydrogen ion. And so the more hydrogen ions you have in a substance, the more acidic it becomes. And so therefore, hydrochloric acid, or HCl, is an acid. So very similarly, we have a base. A base is, once again, a substance that when dissolved in water, it's going to break down, but this time it's going to break down and it's going to donate an OH-, or a hydroxyl group. So let's write this out. NaOH is our base that we're using. And so if we put this into an aqueous solution, water, what's going to happen is it's going to, water being the universal solvent, is going to break this down. You're going to have Na+ and OH-. Here we go. So you can see the picture here. I have a beaker of water, and I've added NaOH, or sodium hydroxide. You can see the hydroxide part of this molecule here is the OH. And if I put that into the water, so here we have more water, I have sodium ions, positive sodium ions, but once again, this is not important to the discussion. What's important to the discussion is that it has donated these negative OH ions, or these hydroxyl ions. And so the more hydroxyls you have in a substance, the more basic it becomes. All right, and so if we look at our pH scale, let me move up. If you look at our pH scale here, you can see that right here, a neutral substance is 7, so that's going to be water, H2O. And everything below 7 is going to be acidic, and the further away from 7 it goes, the more acidic it becomes. So 0 is a very strong acid. And everything above 7 is going to become basic. So 14 is a very strong base. And remember that this is a logarithmic scale. So something that has a pH of 5, a solution that has a pH of 5, is going to be 10 times more acidic than something that has a pH of 6. And then Let's talk about something that has a pH of 4. A solution that has a pH of 4 is going to be 10 times 10 is 100. It's going to be 100 times more acidic than something with a pH of 6. And the same works with the bases. So something that has a pH of 11 is going to be 10 times 10, 100 times more basic than something that has a pH or a solution that has a pH of 9. Remember that a solution is a substance that is dissolved in water, or a substance that is dissolved in something else. So in this situation, we're talking about hydrochloric acid dissolved in our universal solvent water, or NaOH, sodium hydroxide, is the solute and is going to be dissolved in the solvent water. If you have any questions about this, just let me know and we will figure it out.